Hi, how are you?
Hi, quite okay, thank you.
Thank you. If you could give us like a brief introduction of 5G, what is it? Why is so fascinating? And what does 5G provide that we didn't have before?
Okay. So 5G is of course in many ways just an evolution of 4G, but there's a lot of interesting components to that. So if you look at the history, 2G mobile networks were still packet switch networks. They were designed for voice. You had a little bit of data, but not something that was really that useful. We moved to 3G. It was a real revolution because networks became fully IP-based. We moved away from the old kind of packet switch type of networks, and that of course facilitated moving to real internet applications that you started to see when 3G rolled around. But very quickly you realized speed wasn't there, and that was kind of the big thing with 4G, is that we actually got speeds that were in the megabits per second. You could start watching television over a mobile network suddenly, which you couldn't do before. And with Apple, Google, Android coming in, you saw the explosion of applications. That was really facilitated by the fact that you could get the speeds you needed. So what's the big revolution in 5G? Well, in many ways, we're taking a similar kind of step as we did from 2G to 3G when we went to a full IP network. When we go from 4G to 5G, we go from the tradition of doing custom hardware. So if you look at packet core of a mobile operator today in LTE, most of them are still these big boxes that are designed by only a few companies in the world, because building that dedicated hardware is really, really expensive. And that means that you only have today 3 or 4 vendors of that type of equipment. So one of the big steps in 5G is something you see in the industry as a whole, is virtualization. So we go away from having dedicated hardware to having fully software-defined networks, fully software-based networks. So you could in essence run a core from any kind of cloud infrastructure. Of course, operators, we want to keep them internally, but it's still going to be virtualized environments, virtualized software, which means that it's much easier and much more dynamic. Previously, if your core capacity was running out, what you had to do was go and buy a new big box. That takes time, costs a lot of money, it's a long, long process to get that deployed in your network. With 5G, it says it's going to be the press of a button. Okay, my core capacity is running out, my EPC is running on full speed. Well, I just press a button and off you go, and you have a new virtualized EPC up and running in a matter of perhaps minutes rather than days, weeks, or months. And the other big step in that is, of course, software is always cheaper than hardware. That's why we constantly go from dedicated hardware to software-based products, because software is easier to build. You don't have an enormous capex investment to do up front to actually design hardware and build hardware. So that also means that we're starting to see a lot more companies come into the space that build really important components of the network. So companies such as us that are actually looking to take a big chunk out of a very core component of 5G, which is network slicing. You started to see that trend happening already in 4G. So today you do have virtualized 4G cores, you do have some of those abilities. But that change, that real revolutionary change in the way a network is built, is really going to come to its own in 5G. Of course, that will bring you other things. It will bring you gigabit speeds rather than megabit speeds. It will bring you low latency, ultra low latency rather than the kind of 100 millisecond latency you have in 4G networks. But in many ways, they're all following through from the same thing, that you start building networks based on software, which allows you to do things like mobile edge computing in an efficient manner, which allows you to bring down latency, etc. But a lot of that actually stems from the fact that you start virtualizing all the components of the network, including actually at some point even parts of the radio access network itself.
Okay.
So that for me, I think, is really the big step of 5G.
I know, yeah. It's like a before and after. Okay, so what is network slicing, and what's the role of Cloudstreet in network slicing?
Well, perfect question. So network slicing, actually, if you talked about what is the big step of 5G, so it's virtualization, building completely software-defined network. So network slicing is something that is being enabled by that. So to take an example, today when you have a mobile network, which is for your phone use, your average use, but it's not that necessarily much used in critical communications, because you have other networks for that. You have Tetra networks in public safety, you have specific IoT networks. For example, what network slicing allows you to do is to define, you have one real physical network, but you can virtualize it, so you get many virtualized networks within the same. What will that allow you to do? Well, in essence, it will allow you to get away from having dedicated networks for public safety or for industrial applications or for many other applications, and instead just have one common core network, which you virtualize and create many virtualized networks with different characteristics for different use cases. same infrastructure. Why is that important? Well, of course, it's a matter of cost. It is much more cost efficient to have one network which you can share among many applications and have that network behave the way that vertical requires. So for example, public safety, it's all about ultimate reliability. And that's really the power of network slicing, to be able to use the same common infrastructure, the same common network, but allow that to serve many different verticals via the power of network slicing.
So what do you think the consequences of network slicing will be, and how can they affect consumers, enterprises, and governments too?
Okay. Well, a clear consequence, of course, will be that networks as a whole become cheaper to build, which means that you will have more capacity to build, just overall network capacity, right? Because you don't need to build many separate networks. It will mean cost effectiveness. So that will mean that you will be able to cover more geographical areas because you can put all your money, pool it, and put it into the same network rather than building really separate ones. But also through the power of things like network slicing, it will mean that your user experience will become much better. Because if you are, for example, watching OTT video, then that can easily be put into its own slice, which is configured to provide stable throughput with low latency. So you won't anymore see disturbances when you're trying to watch an important football game, which everyone else is watching. So normally if you do that over an LTE network, it works fine all the other time, but when you want to do that, then suddenly it doesn't work because everyone else wants to do the same thing. Well, if you're separated into a specific slice, which is tuned to that use case, then your overall audio experience will be better. And if you look at that from a non-consumer perspective, it will be the same thing for guys like public safety. They will be able to trust the mobile network because it will, for them, be designed for ultimate reliability. Or for things like self-driving cars or IoT, Industry 4.0, which is very latency dependent, for example. And again, they can utilize that same network and it will provide them the power to do so through network slicing that separates them from everything else that's going on in the network. So overall, we'll get better, more reliable, faster networks that can cater to many more use cases.
So if you please can explain to us the application awareness of network slicing and why is Cloudstreet has an important role within this area?
Okay, so the uniqueness that we bring is the view of the end user, the view of the consumer or the business. So although I gave a good pitch for network slicing as a whole and how it's being defined in the industry, there is one flaw in the thinking that a lot of the large vendors has, which is basically, if you look at this, this is then what network slicing will allow you to do. You split the network into separate logical networks that are defined in different ways. So, if you want ultra low latency, you will use mobile edge computing to achieve that, for example. But ultimately, when you do this, unless you bring in application awareness, if you don't bring in access control to the slice, you basically are creating just yet another best effort network. Of course, that best effort network can be tuned in a way that it is providing a better overall service for that specific vertical. But still, if you don't control the experience specifically for the end user, it is another best effort network. And what will consumers be willing to see and what will they be willing to pay for? Well, both consumers and business users is actually what is delivered to you. So I think that's really what we bring to the table. And what we're starting to see also 3GP and other standardization organizations realize that this is what's needed. What the end user cares about is what do I get when I need it. So if I'm trying to guide my industrial robot, I don't really care about the fact that overall the IoT slice has lower latency. I care about the fact that what do I get when I need 10 millisecond latency for my specific robot for it to work. And that's what we bring, the view of the individual end user. So the ability to actually also orchestrate the RAN resources of the network to deliver exactly what's needed, regardless of the overall congestion of the RAN. Because in many ways, network slicing is ignoring the RAN piece because it's difficult. But you need to take care of it because otherwise you really won't get where you need to be. Which is this ability to say, well, you, Mr. Robot, will have exactly 5 megabits per second because that's what you said you need. You will have exactly 10 millisecond latency because that's what you said that you need. And that requires a whole level of orchestration of access control into the slice, orchestration between conflicting requests, and also being able to deal with what we call contextual awareness. So the ability to ensure that not all slices are available at all times and all locations. Because if I am, for example, take a simple example, a broadcaster, and I want to use the 5G network to transmit a very heavy signal from a football stadium to the studio, then I will be willing to pay quite a lot for that if I can get an SLA which is for me individually and I can trust that it's being kept. But that also means that I shouldn't be able to go and use that slice outside of the time when I bought it and outside of the location when I bought it. So this level of really looking at the individual consumer, potentially even looking at the individual application that is being used by the consumer business and treat all of those separately with what we tend to call sub-slices. So you have a vertical slice for a certain industry, but then you also have a sub-slice with yet more specific considerations for a specific user doing a specific task at that specific given point in time. So that's really, the power of application awareness. And where Cloudstreet has put a lot of effort into that. We were actually working with this even before people coined the term network slicing. Then we used to talk only about the application-aware network. So we owe it to the industry for coming up with a very good term to describe the overall concept of network slicing. But that's why we have a lot of expertise in it, and we also have patents around the specific way of treating the network. And that's really where the piece of the puzzle of Cloudstreet comes in, and that's why we're seeing so much interest in our solution and our way of thinking. And we see other people trying to adapt to that as we move forward.
What does Cloudstreet actually do for clients?
Okay, so I think we do two main things. The first, which is actually quite important, is 5G is of course the future, but today we're in 4G. 5G standardization isn't really even fully complete by 2GPP. But the change to look at a network in a network slice manner is also a large business process change for operators. And operators today are struggling with the fact that they need to find new ways of generating revenue today in order to be able even to afford going forward. So we bring a large part of the essence of network slicing already into 4G networks. So you can start deploying slicing today, you can start settling SLAs today, rather than have to wait for another 2 or 3 years to have a fully deployed 5G network and then figure out how do I actually go about selling this. So that's one key important component. And also the other is, going back to what I was talking about earlier in the application-aware network, is that we provide the means to provide a real SLA to an end user. Not an SLA for the vertical slice or for the network as a whole, but an SLA for you personally. So that when you turn on your Netflix at home and you want to have HD quality, then you know that you will get it because we provide you an individual SLA. Or in an event like this, I guess a lot of people would be willing to pay quite a lot in order to get their WebEx to work or whatever they want to do. So we give you the facility to actually then potentially pay a bit more dynamically based on your need to have a guarantee as and when you need it. And this is the whole application-aware piece and looking at the sub-slicing of the network. So provide you an SLA rather than the network as a whole. And that's what you will be willing to pay for. You don't really care about the network as a whole, but you care about what you get when you need it and where you need it.
So Thomas, thank you so much for all the information you provided, and we'll follow Cloudstreet to see how the network slicing goes.
Well, thank you very much, Maria, for the chance to give this briefing to you today, and we look forward to seeing you again next year.
Same. Thank you.
Thank you.